Welcome to our video lecture on reduction oxidation reactions. I'm going to use the nickname redox to refer to reduction oxidation from here forward because it's a lot easier to say. Our objectives for today, we're going to review oxidation states. Sometimes we refer to these as oxidation numbers or the charges of ions. We're going to define reduction and oxidation. We're going to identify species and chemical equations that are being reduced and that are being oxidized. We're going to write reduction and oxidation have reactions, and then we're going to look at these super cool electrochemical cells, basically how batteries work in terms of reduction and oxidation. Let's remember on our handy-dandy periodic tables what even are these oxidation states or charges. If you don't have a periodic table handy, definitely pause the video and grab it. Make sure that you have these numbers written down. Hydrogen and the alkali metals most of the time are going to have an oxidation state of +2 when they are in compounds. Our alkaline earth metals are going to be +2s. We're going to skip the transition metals. They're kind of weird. They can have multiple oxidation states. That's why we have Roman numerals. Boron's group is going to be a +3. Carbon's word, I'm going to leave it blank. Nitrogen's group is going to be a -3 because when it's in a compound, most of the time it's going to gain 1, 2, 3 electrons to get to that octet rule. Oxygen's group will be a -2 for the same reason. It needs 1, 2 electrons to get to the octet rule. The halogens, most of the time, they only need 1 electron to look like noble gases, and so they're going to have an oxidation state of -1. And then our noble gases, most of the time, are going to be zeros because they are neutral. They neither gain nor lose electrons most of the time, and so we're going to give them oxidation states of 0. This is going to be important on the next slide. Neutral is going to be oxidation state of 0. All right, so let's apply this to a chemical equation. What does it even mean? So I'm going to start off by looking at iron and oxygen forming some iron 3 oxide. Remember that oxygen's charge is a -2. Iron's a transition metal. How are we going to figure out its charge? We're going to do a little bit of math. I'm going to balance charges, or unbalance the charges perhaps. So -2 on an oxygen, there are 3 of them. That's a total of -6, which means that my iron has to add up to a total of +6 to balance out those charges. I have 2 of them, so I need iron to be a +3. +3 times 2 gives me that +6. But what about iron by itself and oxygen by itself? Elements that are neutral, that have not yet given away any electrons or gained any electrons, have oxidation states of 0. This iron here has an oxidation state of 0 because it's neutral. It has not yet given away any electrons. The oxygen here has an oxidation state of 0. It's an element by itself. It has not yet gained any extra electrons. What does this mean in terms of what oxidation and reduction are? So, oxidation is the loss of electrons. If we look at iron, iron went from a 0 to a +3. Remember that a +3 means that you lost 3 electrons, and now you have 3 more protons than you have electrons. Losing electrons makes you positive because you have less negative stuff. Iron went from 0 to +3. It lost electrons. Iron was oxidized. Oxidation is the loss of electrons. Iron went from a 0 charge, it had all its electrons, to a +3 charge. It lost 3 electrons. Iron was oxidized. Meanwhile, oxygen was reduced. Oxygen was reduced. Reducing is gaining electrons. I know that feels really weird because reduction usually means like you have less of something, you went down. But here's what happens. It's really amazing and kind of counterintuitive. When you gain electrons, you get more negative, which means that your oxidation state went down. It got more negative, which is reduced. Good, more negative, reduced. So our oxygen here went from a 0 down to a -2. We went from 0 down to -2 because it gained electrons. It gained electrons, it was reduced. Iron was oxidized, oxygen was reduced. How can you remember that losing electrons is oxidation and gaining electrons is reduction? My friends, Leo says grr. Lose electrons is oxidation. gain electrons is reduction. Lose electrons, oxidation, gain electrons, reduction. Our friend Leo here, he says GR. Leo says GR, lose electrons, oxidation, gain electrons, reduction. Let's do some more practice. So again, which element lost electrons? Iron lost electrons. Did its oxidation state go up or down? The oxidation state went up. Was it oxidized or reduced? Iron was oxidized. Which gained electrons? Iron, not iron, oxygen. Oxygen gained electrons. And this is where things feel a little bit weird. It got more stuff and its oxidation state went down. Oxygen gained more electron. It has more negative stuff. Its oxidation state went down. It got more negative. It was reduced. Here's another example for us to do together. Sodium here is an element by itself, and so to find the oxidation state of it, we're going to make it neutral. In this compound, chlorine is a halogen. It's going to be a -1 charge. Iron is still a transition metal. -1 times 2 is going to give me total -2 charge from all those chlorines, which means that iron has to be a +2. There's only one of them, and so this iron has to be a +2. Sodium chloride here, that chlorine is still a -1. Now that sodium is in a compound, it's a +1. Iron is now single element neutral, oxidation state of 0. Which guy was oxidized? Remember that oxidation means that we have lost some electrons. Leo says GR, lose electrons is oxidation. So I want to know who lost electrons. Who lost electrons? Sodium lost electrons. And how do I know sodium went from a 0 to a +1? The oxidation state went up, and the reason is it lost negative things. It's less negative, which makes it more positive. Sodium, we took away 1 electron that has a -1 charge. If you minus a -1, you get a +1. So sodium's a +1 because it lost 1 electron. It now has 1 more proton than it has electrons, which makes it positive. Good. So if sodium lost electrons, sodium was oxidized. Sodium was oxidized. So now I want to know what was reduced. What was reduced? Whose charge went down? Well, that's going to be iron, right? So if we look at iron's charge, iron started at a +2 and went down to a 0. Iron started at a +2 and went down to 0. Iron used to be giving away 2 electrons, and now it has all of its electrons back. We went from a +2, we added 2 electrons that were negatively charged, and now it has a charge of 0. It's back to neutral. So iron gained electrons. That means that iron was reduced. Iron was reduced. What about chlorine? Was chlorine oxidized or reduced? Well, it started at a +1 and then it went to a +1. Nothing happened. So if I've got a redox reaction and we have ions that are not changing charges, they're kind of just watching all the species around them change charge, but they're not doing it themselves, we call those guys spectator ions. Of course, they don't actually have eyeballs. They're not actually watching anything, but you can kind of pretend like they're hanging out watching everybody else change oxidation state, but they're not. So they're spectator ions. So quick review types of reactions. Of course, this is a redox reaction, but is it also synthesis? No. Combustion? No. Decomposition? No. Single replacement? Yes. This is a single replacement reaction. How do we know? I have sodium single over here. It's going to replace the iron on the chloride, and then iron is going to be single by itself. All right, friends, this one is yours to do on your own. Remember to write oxidation states of each of the elements. Remember that our elements that are by themselves, not in compounds yet, are neutral. They're going to have oxidation states of 0s. In those compounds, we're going to have oxidation states from our handy dandy periodic table. So here's some hints. Think about What does it mean for potassium to go from a 0 to a positive 1? What does it mean for chlorine to go from a 0 to a negative 1? What was oxidized? What was reduced? All right, so potassium, chlorine, potassium, chlorine. Potassium went from a 0 to a positive 1. Potassium went from a 0 to a positive 1. That means that it lost an electron. Potassium was oxidized. Chlorine, meanwhile, went from a 0 to a negative 1. Notice that it went from a 0 down to a negative 1 because it went down to a negative 1. It was reduced. Let's do another one. All right, we're going to do another example. I'm going to have you pause here in Edpuzzle and figure out who's oxidized and who's reduced. But we're going to do charges together because this guy is kind of wackadoodle. So in NH3, usually the species more to the right in the formula is going to be the one that's negatively charged. But in this instance, we flip it around. The hydrogen is a positive 3. The nitrogen is going to be a negative 3. Oxygen as an element is going to be neutral. It's going to have a charge of 0. I'm going to do the water first because it's easier. So oxygen negative 2, hydrogen positive 1. This makes sense. This is where things get crazy sauce. So I'm going to start on the right side of the formula, and I'm going to give oxygen its negative 2. If I'm looking at the periodic table, I want to give nitrogen a negative 3, but that doesn't make a 0. This is definitely not balanced charges. And then you might be thinking, but wait, this is not an ionic compound. These guys don't have charges. They're sharing electrons. They are not transferring electrons. And so how does this even work? How do we give them oxidation states? Well, we pretend, we round up and down a lot. So in nitrogen monoxide, we've got these electrons being shared. But because oxygen is more electronegative, remember that? Ooh, electronegative. I can spell. Because oxygen is more electronegative, the electrons are going to be more closely attracted to oxygen, which means that oxygen is going to be a little bit more negative because the electrons are just hanging out over here more. If the electrons are hanging out over there more, that means that this guy is left to be a little bit positive because the electrons are closer to the oxygen most of the time than they are to the nitrogen, which means that in this crazy twist of events, what we're going to do is not give nitrogen a negative 3 charge, but instead we're going to give it, are you ready for this, a positive 2 charge. We're going to get rid of that negative 3 and we're going to make it a positive 2. So we're going to give nitrogen that positive 2 charge. So now I want you to think about whose charges are going up. What's being oxidized? Whose charges are going up? Leo says grr. Lose electrons, oxidation. Lose electrons, get less negative, get more positive. Who's gaining electrons and getting more negative? Whose charge went down? Leo says grr. All right, so we had a negative 3, a positive 1, a 0, a positive 2, a negative 2, a positive 1, and a 0. Oh, not a 0. Oh my goodness. Negative 2. Sorry, I was looking at the O and thinking anyhow. Oxygen here is a negative 2. So nitrogen went from a negative 3 to a positive 2. That's way up, right? Going from negative 3 all the way up to positive 2. This is losing electrons. Nitrogen was oxidized. Nitrogen was oxidized. Meanwhile, this oxygen guy went from a 0 down to a negative 2, down to a negative 2. Because oxygen gained electrons and got more negative, it gained electrons, it got more electrons, it got more negative, it was reduced. All right, let's look at another example. So what we're going to do here is actually take our equations apart and write just the reduction part of the reaction and just the oxidation part of the reaction each by themselves. So this equation right here, notice that I had sodium by itself. It has a charge of 0. It's neutral. It has all of its electrons. Here, sodium has a charge of +1, and then there's electron that is separated from the sodium. This sodium lost an electron. There it is going away. So this is losing electrons. This is an oxidation half reaction. This is an oxidation half reaction. I'm just showing in this equation that sodium is being oxidized. Sodium had electrons, it lost an electron. This is oxidation, and here's that electron that sodium lost. Over here, I have a reduction half reaction. This is our reduction half reaction because it's showing just the reduction half of the reaction. So chlorine here has a charge of 0. It's neutral. It's just chlorine by its chlorine self. And we're gaining these 2 electrons. We're adding or gaining electrons. And that's going to give us 2 chloride ions that are each negatively charged. Because we're gaining electrons, this is a reduction half reaction. We went from a 0 down to a -1. We did that by gaining electrons. Good? So what we're going to do together here is figure out our half reactions. So first up, we need to figure out what's being oxidized and what's being reduced. So what is the charge on our potassium? Potassium here is going to be a neutral 0 charge. Calcium chloride, chlorine's a -1, calcium's a +2. Calcium here by itself is going to be a neutral 0. Chloride's a -1. Potassium's a +1. Notice that potassium went from 0 up to +1 because it lost electrons. It was oxidized. So to write our oxidation half reaction, I'm going to write that potassium went from potassium to potassium +1. And here's the electron that it lost. Potassium neutral went to potassium +1, and then the electron that that guy lost. This is our oxidation half reaction. What about our reduction half reaction? Who was reduced? Whose charge went down? That's going to be the lovely calcium. Calcium went from a +2 down to a 0, +2 down to 0. So let's see here. To write our reaction, we're going to go from calcium +2. We're going to add electrons and get to calcium 0. Is 1 electron sufficient though, my friends? We're going from a +2 down to 0. How do I do that with only 1 electron? I can't. We need 2 electrons here. So +2 plus those -2 electrons gets us to that neutral charge of 0. This one is our reduction half reaction. What about chlorine? What's chlorine? Remember that chlorine, because it's not changing its oxidation state, this chlorine guy, -1 is going to be a spectator ion. Good? Good. So this one, I'm going to have you figure out charges on your own, figure out who's oxidized, who's reduced, and then I want you to find the oxidation half reaction and the reduction half reaction. All right, so remember that oxidation is losing electrons, and because lithium went from a 0 up to a +1, it lost that -1 charged electron. Lithium lost electrons because it was oxidized. The silver, meanwhile, went from a +1 down to a 0. Silver was reduced. It gained that 1 electron. It went from silver with a +1 charged. It gained that negatively charged electron. That positive and that negative made it silver neutral. This is our reduction half reaction. RXN is shortcut for reaction. Let's talk about the oxidation half reaction. What does it look like? So lithium used to be neutrally charged. It turned into lithium +1 charge, and that electron got away. Where do you suppose that electron went? Probably over here to silver. This one is our oxidation half reaction. All right, let's do one more example. So again, find what's oxidized, find what's reduced, find the oxidation half reaction, find the reduction half reaction. Okay, zinc is a 0. Sulfate is a -2, which means that this copper has to be a +2 to balance out those charges. Copper here is now a 0 because it's an element by itself. Sulfate is still a -2. Zinc is going to be a +2. You could have also written all of the teeny tiny little oxidation states within sulfate. So if you'd rather do a -2 here, oxygen is going to be 4 of them. 4 times -2 is -8, which means that the sulfur has to be a +6. So that the whole thing is a -2. That's just crazy sauce. I would rather us just say that sulfate is a -2. Sulfate is a -2. Good? All right. So what was oxidized? Whose charge went up? Zinc went from a 0 up to a +2. Zinc lost electrons. It was oxidized. That half reaction looks like this. We started with neutral zinc. It went to zinc with a +2 charge and 2 electrons that got lost from that zinc. Meanwhile, notice our copper. Copper went from a +2 to a 0. It went down. It was reduced because it gained electrons. Our reduction half reaction is going to be, whoa, that was weird. Copper with a +2 charge is going to gain those 2 electrons and turn into copper with a 0 charge. So last little idea here. This is an electrochemical cell. This is basically how batteries work if we took batteries and made them big and separate, took all the pieces and parts and made them separate. So what happens here? I have this anode. Oxidation happens on the anode. Remember that oxidation is losing electrons. This piece of zinc metal is going to lose electrons. Those electrons are going to flow through this wire over to this piece of copper. The copper that's here in the solution, is going to take those electrons and turn into copper metal, and that copper metal is going to come and stick to the cathode. The cathode is where reduction happens. We're going to gain electrons over here. Because we have a movement of electrons, electrons moving is electricity. So we can actually use this chemical reaction to move electrons through this wire, which means that we're going to have a little bit of electricity formed. We're going to see some volts. We're going to see a current. What's kind of cool? Things are being oxidized. Our zinc is being oxidized. Zinc is going from solid zinc. It is going to, ooh, that's wrong. We're not adding those. We're going to put those 2 electrons over here. So zinc is losing 2 electrons. Those 2 electrons are going to flow through the wire over here to copper. The copper ions are going to grab those 2 electrons and turn into solid copper. So species being oxidized, this zinc metal is being oxidized. Which species is being reduced? The copper ions are being reduced. And when these copper ions get those electrons, they turn into copper metal that's going to stick to the cathode. Guess what's going to happen to the cathode when it has more copper atoms stuck to it? It's going to gain mass. So the cathode, that piece of copper, is going to get a little bit heavier. Cool beans, right? We did it, my friends. We reviewed oxidation states. Make sure that you have those written on your periodic table. We defined reduction and oxidation. Leo says Gur. Sorry, I wrote Gur first. Leo says Gur. Losing electrons is oxidation. Gaining electrons is reduction. We figured out how to find which things in chemical equations are being reduced and which are being oxidized. We wrote some reduction and oxidation half reactions. And we very briefly talked about those electrochemical cells. Good work.